Good evening, students. This is Ankit Joshi. I welcome you all to India's largest live learning platform, Gradeup. So, in today's session, we will be dealing with a very important topic of probability, that is Poisson's distribution. So, this is about me. I am Ankit Joshi. I have been teaching in this domain for more than 15 years. And yes, my subjects of interest are engineering mathematics, signals and systems, and analog circuits. So we want to make an announcement for you. This is regarding the last date to avail discount. See, this discounts Gradeup offering for 12-month subscription or 18-month subscription or 24-month subscription today and on 10th December. There is a lot of difference. You can see this. So for example, for instance, we go for 12-month subscription. The price you are getting today is 16,800 for 12-month subscription, and the same will be hiked to 22,200. So there is a lot of difference between what you can avail today and on 10th December. So requesting you, if you have a mood to join Gradeup platform to prepare GATE or ESE seriously, then you can take up the advantage. Be in time, take this advantage. This is regarding currently which batches are going on. So Vision 2022 will be the best one, and rank up batch, gear up batches are also the part which is going on Gradeup platform. So these are the faculties dealing with the ECE batches for different courses. Along with me, you can see Rakesh sir, Sanjay sir, MN Ramesh sir, Chandan Jha sir, and Chaitanya Reddy sir. So these are the advantages of green card. For any other information, you can contact at the number given below, 9650052904. Yeah. So this is our first frame. I want to start Poisson's distribution. Can I have your response? Yes. So we will start the session. Poisson's distribution. So if you have a discrete random variable, just a moment. Am I audible? Shall we start? Yes, sir. So if capital X is a discrete random variable following Poisson's distribution, then the probability function, that is probability mass function, this is given by P of x equal to e raised to minus lambda, lambda raised to x upon factorial x. This is the probability function, that is probability mass function for Poisson's distribution. Okay. Now what is this lambda? This lambda is Poisson's parameter. There are two ways by which we can calculate lambda. So lambda is alpha into delta t, where alpha denotes the number of occurrence of an event per unit time, and delta t denotes the number of units of time. So there will be two types of problems in Poisson's distribution. There will be one type of problem in which lambda calculation will be involving this formula alpha into delta t. Okay, so if this lambda belongs to some other type, second variety, then lambda can be calculated as n into p, where n represents the number of trials and p denotes the probability of success. Once again, when capital X is a discrete random variable following Poisson's distribution. Following Poisson's distribution means following Poisson's law. In that condition, probability mass function or probability function or probability distribution is given by this format: P of x equal to e raised to minus lambda, lambda raised to x upon factorial x, where lambda is Poisson distribution parameter. Lambda is very important and it is Poisson's distribution parameter. Now lambda can be approached in two ways. Lambda को calculate करने के दो तरीके हैं. There are two ways by which we can calculate lambda. One way is lambda equal to alpha into delta t, and another format is lambda equal to n into p. So there are two different contexts in which the different formula for lambda will be utilized. Okay, so I will be letting you know each and everything one by one. So in the first format, lambda is alpha into delta t. Now the question arises to my mind, what is alpha and what is delta t? So alpha denotes the number of occurrence of an event per unit time, and delta t denotes the number of units of time involved in the probability calculation. कोई भी probability calculate करते समय, whenever you are calculating a probability, then how many units of time are involved in that probability calculation? That is delta t, number of units of time. Coming to the second context, lambda is n into p. So this n denotes the number of trials and p denotes the probability of success. Now again, one more question comes to my student's mind. Sir, you said that this capital X is a discrete random variable following Poisson's distribution, following Poisson's law. What does it mean? What does it mean? Listen carefully. When some trial is following Bernoulli's trial, when Bernoulli's trials are existing, when Bernoulli's trials are existing and number of trials n is very large. Listen carefully. In case of Bernoulli's trial, we apply binomial distribution. जब भी Bernoulli's trial होंगे, we will go for binomial distribution. In case of Bernoulli's trial, we'll go for binomial distribution. But n should not be very large. N should not be very large. N should not be very large. Number of trials should not be very large. Take care. If number of trials are very large, then binomial distribution fails. Binomial distribution fails. So when you have Bernoulli's trial and number of trials are small, you can go for binomial distribution. In case of Bernoulli's trial, when number of trials n becomes large, then binomial distribution fails. Now, the question comes to our mind, what should be done next? If binomial distribution is not applicable, then what should be done? So in case of Bernoulli's trial, when n is very large, you have two options. Calculate n into p. If n into p is less than or equal to 20, in that case, you can go for Poisson's distribution. And in case when n into p greater than 20, you can apply normal distribution. So Poisson's distribution and normal distribution are applicable in case of Bernoulli's trial only. In case of Bernoulli's trial only, Poisson's distribution and normal distribution both can be applied, but they are applicable under certain condition. So once again I am repeating the concept. In the condition of Bernoulli's trial, if number of trials n is small, then you can go for binomial distribution. When number of trials are large, then you have to calculate n into p. You have to calculate n into p. If this n into p is less than equal to 20, you can go for Poisson's distribution. And if this n into p is greater than 20, you should go for normal distribution. This is the logic. Okay? Remember. Now, this n into p less than equal to 20, Poisson's distribution, the same condition is applicable to alpha into delta t also. Alpha into delta t, this product should be less than equal to 20 in order to apply Poisson's distribution. And in this case, n into p should be less than 20. Is that clear? Is that clear? Can I have your response? जवाब ही नहीं आ रहा है आपका तो. You are not at all responding. Requesting all of you to hit the like button. Now see here, variance and standard deviation of Poisson's distribution. Okay, so remember, mean of Poisson's distribution is denoted by E of x, and this is nothing but lambda. And variance of Poisson's distribution is also lambda. Remember, so mean of Poisson's distribution is equal to variance of Poisson's distribution. Remember this. In case of Poisson's distribution, mean equal to variance equal to lambda. Mean equal to variance equal to lambda. We will solve an example first. See here. On an average, number of accidents occurring per day on a highway is 3. It should be per month. On an average, number of accidents occurring per month on a highway is 3. It means they have given you alpha. What is alpha? Number of accidents per month. So here alpha is given as 3. 3 accidents per month. Yes or no? Yes, sir. Now, I can see Abhi Krishnan, Alok Goyal, Akash Bhargav. Beta जो online है, whoever is online, kindly respond. This is a boost up for me. And requesting all of you to hit the like button. Share the link among your friends also. So alpha equal to 3. Now, what is the occurrence mentioned here? Occurrence is accident. And what is the unit time involved in the calculation? Sir, unit time is month. So a unit time can be month, day, year, hour, second, minute, but which time unit is involved in the problem? Month. They have mentioned the problem in terms of month. So unit time is month. Please concentrate. If you understood this question, then you are going to learn a unique variety of problem related with the Poisson's distribution. So alpha is the number of accidents per month. Alpha is given as 3. Here accident is the occurrence and unit time is month. Is that clear? Okay, sir. Now, see the first question. Exactly 5 accidents in consecutive 2 months. Okay. So, in this first part, how many unit time is involved in the probability calculation? In this part, how many units of time are involved? कितने units of time involved है यहाँ पर? How many units of time are involved in the first problem? Sir, 2 months. It means 2 units. 2 units. So delta t, shabash, delta t will be 2. And alpha will remain same for all of these. Alpha is the universal statement. Alpha will be 3. Okay, sir. So number of accidents per month is 3. And number of months involved, number of unit time involved is 2. Now, what is lambda? Lambda is alpha into delta t. What is lambda? Alpha into delta t. Alpha is 2. Alpha is 3. Delta t is 2. Lambda will be 6. So, by Poisson's distribution, P of x will be equal to, बोलो भाई बोलो, आवाज करो, shout, e raised to minus lambda, lambda raised to x upon factorial x. So this is the Poisson's distribution. This is the Poisson's distribution. Now, what you have to do? Exactly 5 accidents. You have to calculate the probability for exactly 5. Lambda is given as 6. So probability for exactly 5 accidents in consecutive 2 months. So here the number of accidents is denoted by x. So x is 5. E raised to minus 6. 6 raised to 5 upon factorial 5. Okay? Yes, sir. So if you wish to calculate further, you can calculate, or else what you can do? You can calculate this coefficient 6 raised to 5 upon 5 factorial. $64.8. So this is the answer for the first part. Coming to the second part. Meanwhile, I request all of you to take the screenshot. Now, more than 2 accidents in a given month. More than 2 accidents in a given month. So in the second part, how many units of time are involved? अरे भैया second part में delta t कितना है? What is the delta t? In a given month means 1 unit time. Delta t is 1 and alpha will remain 2. So in the second part, alpha remains same, but delta t is given as given month, given time. Given time means delta t is 1. So what about lambda? Sir, lambda is alpha into delta t. Okay. So 2 into 1, that will be 2. By Poisson's distribution, e raised to minus lambda, then what? Lambda raised to x upon factorial x. Now what is the value of x here? More than 2 accidents. Hello, more than 2. So if x is counting the number of accidents, then we have to calculate probability for P of x greater than 2, more than 2. So more than 2 means 3, 4, 5, 6. So this will go up to infinite, upper limit. So it will not be possible for us to calculate all these values. So we will just think of the opposite case. So what, which values are left here? क्या क्या छूट गया है यहाँ पर? The values of x left out here is 0, 1 and 2. So both of these are opposite to each other. So to equate them, you have to subtract this from 1. So for x equal to 0, for x equal to 1, for x equal to 2, you have to write this formula. So e raised to minus 2 will be common in all the terms. X equal to 0. In this part, you have to put x equal to 0. So 2 raised to 0 upon factorial 0 will be 1. 2 raised to 1 upon factorial 1 will be 2. 2 raised to 2 is 4. 4 by factorial 2 is 2. So very easily I can say that it is 1 minus 5 times e raised to minus 2. And leave it as it is. Answers will be mentioned in this part. Abhikrishnan, alpha will remain same for each of the cases. Alpha is the common statement given. On an average, number of accidents occurring per month on a highway is 3. Okay, it is given as 3. Extremely sorry. Alpha is 3. Alpha is 3. अरे भाई मिसप्रिंट हो गया, मुझे लगा 2 दिया था. So alpha is 3. Alpha is 3. So 3 into 1, that will be 3. कोई बात नहीं, चेंज कर देते. 3 raised to x. Then what? यहाँ पे चेंज हो जाएगा. e raised to minus 3. Then what? Yes. So 3 raised to 0 by factorial 0 is 1. Then 3 raised to 1 upon factorial 1 is 3. 3 raised to is 2. That is 9. 9 by 2 is 4.5. So it is 1 minus 8.5 e raised to minus 3. This will be the answer. Take the screenshot. We'll move to the next part. At least 2 accidents in a period of 3 months. So in this case, delta t is 3 and alpha is again 3. Alpha is 3 and delta t is 3. So lambda will be alpha into delta t. 3 into 3, that will be 9. By Poisson's distribution, e raised to minus lambda, lambda raised to x upon factorial x. Now what to calculate? पीछे देखो पीछे. At least 2 accidents. कम से कम 2, minimum 2. At least 2. 2 or more than 2. At least 2 means 2 or more than 2. Okay, sir. Okay, sir. At least 2. 2, 3, 4 and so on. So we will do the opposite. 1 minus p of x equal to 0 and 1. 1 minus. Put x equal to 0 and 1. In both of these cases, e raised to minus 9 will be common. When you put 0, that will be 1. When you put 1, it is 9 upon 1, that is 9. So all my Laddu students have got the answer 1 minus 10 e raised to minus 9. This is the final answer for this case. So can I have your response? Now see here. No accidents in a period of 2 months. Okay, 2 months. So alpha is 3, delta t is 2. Lambda will be product of these two, that will be 6. P of x. We are not charging anything to you. We are just making it for free. Still, some students disliked it and moved out. It's okay. E raised to minus lambda, lambda raised to x upon factorial x. E raised to minus 6, 6 raised to x, factorial x. So they are asking for no accidents, 0 accidents. This will be the answer. So I hope you patched up with this concept. अमित भाई पानी का बॉटल देखो बिना। Fundamental concept of Poisson's distribution. Next. Okay. If mean of the Poisson's distribution 0 factorial is 1. Rohini, Bhaskaran, 0 factorial is 1. If mean of the Poisson's distribution is 2, find expectation x square. This is another important concept. See here. For Poisson's distribution, mean and variance both are equal. Mean equal to variance, and this is nothing but the Poisson's parameter lambda. Now see here. We know from our childhood days that variance of x is expectation x square minus expectation x whole square. But variance of x is nothing but lambda. Okay, sir. Expectation x square is unknown. That's also great. Expectation of x, that is mean value, that is lambda. So lambda square plus lambda will be expectation x square. So expectation x square will be, they have given you the mean value, lambda is given, so 2 square plus 2, 4 plus 2, that will be 6. Answer will be 6. Can I have your response? Can I have your response? Can I have your response? So this is a very important concept regarding Poisson's distribution. For Poisson's distribution, mean and variance are equal. Now see here. For a Poisson's distribution, just a twist of concept. For a Poisson's distribution, expectation x square is 6. Find mean value. Find mean value. Since we know that variance equal to expectation x square minus expectation of x whole square. Okay, sir. Variance of x is nothing but lambda. Expectation x square is given as 6. Expectation of x is lambda for Poisson's distribution. So you are getting a quadratic equation. So on solving this, you are getting lambda plus 3 and lambda minus 2. Correct? Good evening, Golu. So lambda will be minus 3 and lambda will be plus 2. So this lambda denotes mean. So as far as the mean is concerned, both the values are okay. But in Poisson's distribution, mean and variance both are equal. So variance cannot be negative. So this cannot be the value of mean. Arey bhai, in case of Poisson's distribution, mean and variance are both equal. So your mean should be selected such that it should satisfy the properties of variance also. Is that clear? So why we are rejecting this value? Why we are rejecting this minus 3? Because this can be mean, but this cannot be variance. So in Poisson's distribution, mean and variance both are equal. So why we are rejecting this lambda equal to minus 3? Because negative value of variance is not allowed. Okay. So that's why our answer is lambda equal to 2. That is the mean of x. Yes. राइट ए वन लाइनर नोट, एक लाइन का नोट लिख लीजिए आप. The variance cannot be negative, and that's why lambda equal to minus 3 is not allowed. Rejected. चलिए इसकी बात करते हैं. If a random variable x is Poisson's distributed with mean value with mean 5, that is lambda is given as 5, mean is 5. So what is e of x square? That is lambda square plus lambda. Bolo bhai, tell me. Lambda square 5 square plus 5, that will be 30. Now we have to find out this one. ये फाइंड करना है आपको. एक्सपेक्टेशन ऑफ x plus 2 होल स्क्वायर. आकाश, भार्गव, गोलू, अभिकृष्णन, रोहिणी, भास्करन, नवीन, you are welcome to the session. Are you all following the concept? So expectation of x square plus 4 times expectation of x plus 4. So expectation of x square I calculated as 30. Any doubt in this? 4 times expectation of x is nothing but lambda, that is 5. So 30 plus 20, 50 plus 4, 54 should be our answer. Tan tan tan. Come on, fast. Requesting all of you to hit the like button. Share the links. Click the bell icon. Subscribe our channel so that you will be getting notified regarding our sessions. At a busy traffic intersection, the probability P of an individual car having an accident is P equal to 0.0001. If 1000 cars passing through the intersection every day. So how many times this experiment is performed? 1000 times. If a car passes through a traffic junction, the probability that it meets an accident is 0.0001, and 1000 such cars are passing through the junction every day. Okay, yes sir. So here number of trials are large Probability of success is small. See here, n is large and p is small. So now you can calculate n into p. So what will be the answer you will be getting? N into p? Check me, tell me. 0.1. So this 0.1 is a moderate value. It is less than equal to 20. So this is our lambda. This is our lambda. So this problem belongs to the second category. So by Poisson's distribution, lambda raised to x okay, Akash, we'll plan something more. E raised to minus lambda, lambda raised to x upon factorial x. So this is our Poisson's distribution format. Is that clear? Now what they are asking for, the probability that two or more car accidents, two or more, x greater than or equal to 2. Two or more car accidents occur in a day. Arey bhai, so this will be 2, 3, 4 up to infinity. So we will consider the opposite case. हम इसका opposite consider करेंगे. 0 and 1. Yes. So 1 minus p of x equal to 0 and 1. So 0 and 1. So e raised to minus 0.1 will be common. And when you put 0, that will be 1. When you put 1, it is 0.1. So this is the probability for two or more accidents on a particular day. Yes, sir. Done. Chalo bhai, we'll move to the next. Good question or good section. What you want to write? I don't know. Anyways, suppose P is the number of cars per minute passing through a certain road junction between 5 p.m. to 6 p.m. Okay. For during this 1 hour slot, P is the number of cars passing per minute. And P has a Poisson's distribution with mean 3. Okay. So mean is given as 3. So lambda is given. What is the probability of observing fewer than 3 cars? Arey bhai, fewer than 3 car means x less than 3. So you can form the Poisson's distribution. Haji, e raised to minus 3 lambda raised to x upon factorial x less than 3 car means 0, 1 and 2. So when you put 0, 1, 3, e raised to minus 3 will be common. Put x equal to 0, 1. Put x equal to 1, you will get 3. Put x equal to 2, 3 square, 9. 9 by 2, 4.5, 4.5. So we are getting 17 by 2. E raised to minus 3. Check karo. Actually, this bracket should be here. ऐसा होना चाहिए bracket. Okay, e raised to 3 is taken in the denominator. Okay, well and good. Correct. Everything is perfect. So you can take this to the denominator. Option C. You can hit the like button. That is the only way you can motivate me to teach you. Done with this? Very good. Shabash. Now see here. An unbiased coin is tossed an infinite number of times. Okay. So even if you toss a coin for the first time, what is the probability of head and tail? Probability of head will be 1 by 2. Probability of tail will be 1 by 2. If you toss the same coin for the second time, will the probability change? No, probability will not change. Probability will not change. So tossing a coin is nothing but a Bernoulli's trial. So Bernoulli's trial can be defined as an experiment in which probability of success and probability of failure remains unchanged in subsequent trials. In each subsequent trial, probability of success and probability of failure should not change. That is Bernoulli's trial. So they are saying that an unbiased coin is tossed an infinite number of times. It means this experiment is Bernoulli's trial. The probability that the fourth head appears at the 10th toss is, yes, see, there are total 10 tosses. Our observation is up to only 10th toss. So I am dividing this into two parts. So this first part covers 9 tosses, and of course this last toss will be called as 10th toss. Okay, sir. So please see here. For this 9 tosses, number of trials will be 9. For this 9 tosses, number of trials will be 9. Probability of success will be 1 by 2. Probability of failure will be 1 by 2. Okay, sir. So for this first 9 tosses, you have to write the binomial distribution. By binomial distribution, for Bernoulli's trial, if n is not very large, you can apply binomial distribution. So by binomial distribution, NCX P raised to x Q raised to n minus x. Now, okay, thank you, beta. So out of these 9 tosses, if you get 3 heads, see how many heads you require. You want 4th head should appear in 10th toss. What you want? 4th head should appear here. So we are fixing one head here. हम यहाँ पर एक head occur करा लेते. So if one head is occurring at last, so how many heads are required in 9 tosses? We require 3 heads. So please combine these two events. If you are getting 3 heads in 9 tosses and you are getting one more head in the 10th toss, you can say that this is 4th head. This is 4th head in the 10th toss. So 4th head in 10th toss will be the product of two probabilities, P1 and P2. P1 is probability of getting 3 heads in 9 tosses. Acha. P1 is probability of getting 3 heads. So x will be 3. 9C3, 1 by 2 raised to 3, 1 by 2 raised to 9 minus 3, that will be 6. So 9C3, 1 by 2 raised to 3, 1 by 2 raised to 6, that will be 1 by 2 raised to 9. So this P1 is probability of getting 3 heads in 9 tosses. Now one more time the coin is tossed. So that toss is 10th toss. And if again you are getting one more head, so probability of getting one more head, probability of getting head in the 10th toss is an independent event. It is 1 by 2. So overall probability of getting 4th head in 10th toss, this will be P1 into P2. P1 into P2, P1 into P2, 9C3, 1 by 2 raised to 9 and again 1 by 2. So overall it is 9C3, 1 by 2 raised to 10. और जिनको 9C3 कैलकुलेट नहीं करना आता है, 9C3 factorial 9, factorial 3, factorial 9 minus 3, that is 6. So 9 into 8 into 7 into factorial 6. Factorial 3 is 6 and factorial 6 as it is. Both will be cancelled. Now you can calculate this. 6 is cancelled 2 times. Here 3 times. 2 is cancelled 4 times. 4 3s are 12. 12 7s are 84. So 84 1 by 2 raised to 10. 84 1 by 2 raised to 1 by 2 raised to 10. So 84 upon 1024. 84 upon 1024. So our answer is 0.082. Correct. Absolutely correct. Abhi Krishnan. Very good. Shabash beta. Very good. That is wrong, Naidu. Krish, that will be wrong. That will be giving you, see, probability of getting 4 heads in 10 tosses. That is different from probability of getting 4th head in 10th toss. Krish, Naidu, both of these are different. They are not same. Okay. So what you are asking directly we can take for 10 tosses. This is this first case. Or that is the point I want to make. Students do not realize the difference between these 2 points and they assume that both of them are same and finally they lose the marks in the exam. So you should not lose the mark. You should identify the difference between these 2 cases. That is the point of these classes. This is the aim of this class. Krish Naidu. No response? Okay, it's okay. I'll move to the next. So once again, what they have asked, an unbiased coin is tossed an infinite number of times. The probability that the 4th head appears at the 10th toss is, they are asking for 4th head at the 10th toss. It means the 4th head must appear in the last toss, 10th toss only. Okay, it should not appear anywhere else. So you must ensure there are 3 heads in 9 tosses and then 1 more head in the last toss. That will be the 4th head in the 10th toss. The probability that a resistor being defective is 0.002. Let us denote this probability by small p. And there are 50 such resistors. How many times this is repeated? 50 times. So we can say that n is large. N is large. So binomial distribution will not give you correct result. So you have to find n into p. So n into p, 5 2s are 10, 1 more 0 and 3 decimal places. Correct? So this should be your lambda. By assuming this as the lambda, we can proceed. Arey bhai, requesting all of you to hit the like button. Now by following Poisson's distribution, P of x will be e raised to minus lambda, lambda raised to x upon factorial x. Now The probability of 2 or more defective resistors. Acha, 2 or more, x greater than or equal to 2. Shabash sir, very good. So 2, 3, 4 and so on. This will go up to railway station. Infinite series है. So 1 minus p of, which numbers are left here? 0 and 1. दो ही number छूटे हैं. 1 minus, put 0 and 1. So e to the power minus 0.1 will be out. When you put 0, you will be getting 1. When you put 1, it is 0.1. So this should be your answer. Is that clear? Is that clear? Is that clear? सही नहीं है वो, खराब है बेटा. ये लो. Yes, Mukesh Sinha. So this is some basic concepts, some very important concepts. These were some basic important concepts regarding Poisson's distribution we dealt with. So you need to take care of some important points. Once again, I repeat, in case of Bernoulli's trial, generally we go for binomial distribution, and n should be small. N should be small. If n is large, then binomial distribution not applicable. Binomial distribution fails. And now you have to check n into p. If n into p, this product is less than or equal to 20, you can go for Poisson's distribution. And if n into p is greater than 20, then you can be using normal distribution. So in tomorrow's class, we will be learning about normal distribution, revising the concepts of normal distribution. So this was all about today's class. That's it. So those who have joined late, they can watch the recorded session. And best of luck for your exams. Do let us join again with me tomorrow at 6 p.m. Thank you. Bye bye. Take care. We'll meet tomorrow. Thanks a lot. Tomorrow 6 p.m. normal distribution. Remember.